All right, this is the second attempt. I'm hoping the sound works on this one. So, allotropes and uh, shielding effect. So, allotropes is, write this down right here, each of two or more different physical forms in which an element can exist, such as graphite, charcoal, and diamond, are all allotropes of carbon. So, what this means basically is that the allotropes have different shapes, but they have the same amount of um, they have the same elements in them, which is basically just carbon. Well, sorry, take it back. It is just carbon, but it's taking different shapes. So it right here is graphite, and then this is the diamond, and then this is Buckminster fullerene, which we call buckyballs. Okay. So again, here's allotrope of carbon. Graphite, and it's used in our pencils. And then it kind of like layers like this and kind of has this simple shape to it. An allotrope of carbon and the diamond has a little bit different shape. It's kind of more bent and more has more structure to it. And then when they line up, they kind of build and they make those diamond shapes. Okay. And then buckyballs or bucky tubes kind of make a circle and kind of have this shape to them. And these are the bucky tubes. Okay, the shielding effect. The shielding effect is a decrease in the attraction between electrons and the nucleus of an atom. This is the definition. Please make sure you write that down. Electrons are highly attracted to the nucleus. Why? Because they have a negative charge, and the nucleus contains protons, which is a positive charge. And if we remember, we only have protons and neutrons in the nucleus, so the overall charge of a nucleus is positive. As you add additional electrons, they are present in different orbitals. So the electrons start to repel each other. Why? Because as you have your little shape here, your orbitals, okay? So there's your nucleus. You have two electrons right here. You add another one right here. These both have negative charges, so they're going to start trying to repel each other. Okay, they're going to try to repel away from each other and pull apart faster. Okay. So a strong shield effect will influence the ease in which electrons can be removed, because the further away they get from the nucleus, the more easy they are to remove. And that is called ionization energy. Electrons on the first orbital are very difficult to remove. Why? Because they're very, very close to the nucleus. So if you see, here's the nucleus, then you have this first ring, and it only holds two. The nucleus is going to hold those close together, okay? And they must get past they must, to be able to be pulled off, they have to get through this orbital or any other orbitals that have electrons already on them, okay? So electrons in the outer orbitals are very easy to remove in chemical reactions. No other electrons are blocking them. That's why, okay? Kind of what I was just showing you a minute ago. An atom that has less electrons than usual or more electrons than usual is called an ion, and that's review from before. And just remember we have cations and anions, and remember which one's which. All right, this one's going to be shorter because I rushed it a little bit, but I kind of knew what I was doing in this one more than the other one. So you guys have a good night. This is due Tuesday.